So why the heck did you go from space to cellular agriculture?
That is a good question.
Just love pain?
Yeah, yeah. Love challenge, I think, would maybe be
Yeah.
my, yeah, thought there. I think when I left SpaceX, I knew that there were a couple of things that I really, really loved about the company that I wanted to find in my next adventure. And so one of those things was working somewhere where there isn't a clear-cut solution in an industry that's really forcing the team and the company to think about things in a new way. And so I think as I was researching, different climate tech companies or companies that I felt like were really making a positive impact, cultured meat is one of those industries where there's a lot of opportunity, but I think no one has like cracked the code yet, which means that you can come in and come up with creative out of the box solutions, which was appealing.
Hmm. I love that, especially the challenges part.
Valve announced a new product in Hong Kong. Incredible interview coming up with their head of manufacturing, Ines, who previously came from SpaceX, where she was building rockets. Link to the full interview, as always, in the description.
Can you tell us a bit more about the transition from the Falcon to the Starship in Texas?
Yeah. So I, at that point, was kind of leading our build reliability team in LA. So was leading a team of, I think, 5 or 6 engineers and had been doing that for, I think, just over a year. Starship was kind of starting to get off the ground. I think they had done 4 or 5 really preliminary tests down in South Texas. All of them had failed in some catastrophic way. So they were, continuing to try to test and learn, but were running into a number of technical challenges. And so the head of kind of the SpaceX wide reliability department sort of put out an ask like, we have no one who's supporting the Starship team who's interested in joining this program. And I think everyone at the time was kind of like, this is a shit show. Like, who is going to be the idiot who volunteers to go to this rural town where they clearly don't care about reliability? They're just trying to move as quickly as possible. I think I like thought about it for a moment and was sort of like, this sounds super cool. So I think was probably the only person who put my hand up in an organization of
Wow.
who knows, probably 200, 300 people,
Mm,
because to me, there was something really appealing about being sort of the first boots on the ground person to help and sort of build this team from the ground up was really
mm.
appealing to me. So, yeah, traveled down there a couple of times. It, looked like a construction site in the middle of the desert. Yeah, I think I was sort of like, this when in my life will I be able to do something like this? If not now, when? So yeah, did it. And all my friends in LA thought I was completely crazy. They were like, why would you leave LA and move to Boca Chica? But yeah, I did it.
And what are some other operating principles?
I think a big one, which, Elon constantly repeats, and I think is in kind of the blood within SpaceX, is like simplify, simplify, simplify.
Mm,
And so it's sort of this idea of like, if in doubt, delete the part, the process, or the requirement. It's something that I've tried to really instill at Vow, which is, I think it kind of goes hand in hand with this concept of like extreme ownership and simplification, which is an example, if I'm an engineer working on the design of a component and someone from another team told me that, you know, it is only capable of operating to X temperature.
Mm.
You should never like take that at face value. You should kind of like trust but verify. And you should be trying to understand like who's the person who did the testing to determine that this is actually the requirement. Because I think in so many cases, that requirement might have been established 4 years ago by an intern who did one test. If you let all of those requirements stack up over time, you're going to be over constrained and you're going to be designing a system or a part, whatever it is, that is overly complex. And so, like, do everything you can to kind of boil down to like, what are the true requirements? Who are the individual people who own each of those requirements? Getting like crystal clear on that and then like developing the right solution.
Can you teach us about the development of Starship and maybe have like a particular focus on balancing the trade-offs with speed and reliability and cost?
So the development of Starship was very interesting and very complex. There were a lot of different teams involved, and I think it was like at its core, it was really how can we like learn as much as possible as quickly as possible so that we can get to orbit and learn even more things. And so it always was keeping our eye on like what is the next milestone that we have to get to and how can we sprint towards that as quickly as possible in order to learn as much as we can. And so I have many memories of us having a early prototype rocket at the build site where we, needed a week of time in order to integrate all of the last components before we physically sent it on the road down to the launch site in order to fire up the engines or pressure test the vehicle for the first time. And Elon would kind of pose challenges to the team that seemed, physically impossible, whether it was, you're telling me you need 7 days, there needs to be a rocket on the launch pad tomorrow morning at sunrise. Go.
Oh my gosh. Oh my gosh.
And while I think that is always like stressful to teams, I think it really pushed everyone to come together and be
Yeah.
laser focused on like, okay, we've got 24 hours. Let's like cut out all of the fluff that isn't needed. And it kind of comes full circle back to the requirements that I was talking about, right? Like
Mm.
if you only have 24 hours, every team is going to be critically thinking about like, this is the list of everything I want to do. What are the 2 things that are essential and what are the 98 things that are nice to haves?
Mm.
I think those were some of the fondest memories I have of, people work through the night, but then when you all achieve that, that is really a like amazing moment of both just like bonding and also reminding engineers of like, wow, we thought we couldn't do this, but we can. And it builds the confidence of the team to do the next impossible task that is coming down the pipeline.
What did you observe about the way that teams ramped their ambition and ramped their scale? I mean, even in the first question, you talked about one of the first projects you worked on was achieving something that was 10 times more scalable. And so I'm curious, like that's quite a leap in just a project, but perhaps you can share just the ambition that you observed as the scale of things got bigger and bigger.
Again, just from my observation about how things worked, I think it kind of ties back to this concept of push people to do the impossible and they will land. I think this is another really common Elon quote. I probably misquoting it, but like, we're going to try to do something impossible and then we're going to end up being late. Goes back to like, if you give people a really impossible task, it forces them to think in a different way. And so an example of that, right, would be traditional aerospace had never landed a rocket. Reusability wasn't really a thing. SpaceX said, we're not only going to be reusable, we're going to be 10x reusable. And I think now recently they just landed a rocket on like the 24th flight and there was a failure mode during the 24th landing. And
Wow.
but landing 24 times is a pretty impressive
Unbelievable.
impressive task. And so I actually think to like flip your question on its head, rather than it being a like incremental, how do we go from landing once to landing 10 times? The way they approached it was like, let's challenge engineers to land 10 times. Because if you're designing or a process, an organization to solve the problem, how do you land 10 times? You're going to do it in a very different way than if I told you land twice. And then when you did that, land 3 times. And so I think
Mm.
it's like, rather than actually scaling, it was like, what is the end goal that we want to get to? Let's challenge people to do that. They may not solve that problem. They may only get 75% of the way there. But then once we're there, then let's throw the next impossible challenge out and see how we solve that.
Any frameworks or learnings that were applicable across the Falcon and the Starship?
I think I touched on a number of these things. The one thing I might add is I think another principle other than things like simplifying questioning requirements, like those are things we've already talked about. The third that I think is really translatable to so many different industries, like end-to-end ownership of things. And I think SpaceX did this probably partly through necessity and partly through, desire of rather than relying on external suppliers or kind of being a piece of the solution, how can we have more control over our own destiny,
Mm.
right? And I think that definitely is the case at Vow, which is you should kind of critically think about the partnerships or people that you're relying on, especially in industries where you need to move really fast and you need to do it cheaply. Because I think oftentimes, bringing things in-house, you can achieve a faster, better, and cheaper solution. There's risk in doing that. You're doing something for the first time. You might be, taking on aspects of the business that you didn't expect, but it means that you have a much tighter feedback loop on what's going well, what's not, and you can like problem solve in a much more productive and faster way. And so I
Mm.
think just that kind of concept of end-to-end ownership and evaluating like what can we do ourselves versus what should others be doing.
Let's take a step back and even just describe what the role of manufacturing entails. And like day one, what were some of the responsibilities that you had then?
So manufacturing is really the way I like to think about it is taking a process that we've proven works at a small scale and translating that kind of benchtop process into large scale equipment and then doing that thousands and thousands of times over
Mm.
in a repeatable, reliable way so that we can ultimately operate multiple factories around the world and produce high volume, low cost products. There are a number of different aspects within manufacturing. There's designing, validating, and commissioning different pieces of equipment and factories. There's developing the process, so taking the process that works in small scale and developing it for 20,000 liter reactors, 200,000 liter reactors, whatever's to come in our future, right? And then there is taking the equipment and the process and turning that into a well-oiled machine, which is what is manufacturing's ultimate goal, right? Is how do we create a well-oiled factory that is executing and going through all of the operations from start to finish seamlessly so that we can make sure that any customer around the world who wants our product has it on time and it meets the bar that they're expecting.
What is and why is a big reactor important to Val?
Yes, that is a good question. So it's important for two core reasons. The first is volume, right? The larger the reactor, the more product you can get out.
Mm.
If we want to be feeding billions around the world, we need a lot of product. And the most efficient way to do that is through large reactors. So there's volume and then there is cost. And if you think about it, there are many costs that compose the cost of the product. CapEx is one of those costs. The larger the bioreactor, the more product that you can get out of it, which means that the cost per kilo that you're getting out of that bioreactor is going to be lower.
Mm.
CapEx doesn't scale linearly with size. There is some upfront investment when you are manufacturing a bioreactor. And so the larger the bioreactor is, the cheaper unit cost per volume of product is.
And what did you learn about building the first one that you were involved with?
When I arrived at VOW in September, I was told that our first 15,000 liter bioreactor was going to be arriving imminently, and our goal was to get it up and running by the end of the year. So naturally, that was a very exciting goal for me to be a part of.
Mm.
Our strategy for that bioreactor, which made a ton of sense at the time, was to procure it from a supplier in India who owned the end-to-end process. So they did a lot of the design work with our requirements. They fabricated and validated the system and then sent it over to us. We ran into a number of opportunities and challenges along the way. The first being that we expected to get a lot of support from this supplier during the build and validation on site at VOW. As you can imagine, this is a really large system, so it's shipped to us in small components that we need to assemble in order for us to test the system. And ultimately, that team wasn't able to get the visas they needed to come to Australia. And
No
so
way.
we turned it into an opportunity and basically said, all right, we need all hands on deck here. So we brought in people from the manufacturing team, but also from many other parts of the business, from marketing, from biz ops. And we had bioreactor build parties where through the night we would have teams of people who were just assembling different pieces of hardware and testing different systems. So it was an all hands on deck experience, but I think everyone learned a lot and felt really a part of this milestone, which was really cool. And I think the second learning, which is taking some of what I mentioned previously about SpaceX, was we didn't have much control over our own destiny because we were so reliant on this vendor. And so that shaped a lot of our thinking around, for our next bioreactor, what do we want to do ourselves? And what skill sets or people can we leverage within VOW in order to tackle pieces of this in the future?
Mm.
And so it resulted in us designing our next generation bioreactor from the ground up and really, really simplifying the system, as well as being a bit smarter about our supply chain strategy, where rather than relying on one supplier to deliver the end-to-end system, we could say, where does it make sense to procure the pressure vessel? Where does it make sense to procure the agitator? What about the valves? And we could critically think about who is the right supplier from a cost, but also a logistics perspective. And we, as a result of that, really diversified our supply chain for this next generation bioreactor in a way that has certainly already paid off.
Mm. It reminds me of what George said about you, and he described you as simply fucking incredible and has an unparalleled ability to get people to walking through walls over and over again. What does it mean to be buying down risk in VOW's manufacturing operations?
It is very closely linked to testing as much as possible. And I think this is, again, maybe a personal bias of mine, but you can only learn so much by performing analysis or performing calculations. You learn exponentially more by just doing the thing for the first time. And so we always are like very frequently having conversations about what is the next operation that we want to perform and how quickly can we get there? Because we know that when we do it for the first time, things aren't going to go as planned. And so
Mm.
uncovering those skeletons sooner means that we have more time to solve them.
Mm.
And so similar to at SpaceX, we'll have the conversation of what are the trade-offs, right? We could perform a sterile hold of a new bioreactor 2 weeks sooner, but that means that maybe the automation won't be complete.
Mm.
And so then the question becomes, okay, the automation might not be complete. We can still do this operation manually. Do we still think that we would learn enough by doing this operation manually in order to do it? Or do we think the automation is essential? And more often than not, the answer is we're still going to learn a lot. Let's do it manually. And then when the automation is complete, we can do it again with the automation. And then that gives us two opportunities in order to uncover failure modes rather than one opportunity 2 weeks from now.
What does that mean in the context of building a factory? Run us through the scale of that and what needs to go right.
Building a factory is, it's not an easy problem. And I think the same principles can be applied really, which is how can we learn as much as quickly as possible? And then I think another core principle is how can you understand what decisions are reversible and what decisions are irreversible so that you don't paint yourself into a corner.
Mm.
And what that means is we know that 6 months from now, a year from now, we're going to know so much more than we know today. And so what we need to do is keep our options open until we have to close them.
Mm.
And so how that manifests is, we decided to bring food processing in-house at the start of this year. We made that decision one night, and a few days later, we were digging a hole in the ground in our factory in order to create our food processing box. We know that when Factory 2, which is our first commercial manufacturing facility, is at full capacity with many bioreactor lines, we're going to need a massive food processing area. But in order to build that long-term food processing area, it would take a lot of time and it would take a lot of money. So what we decided is let's build a much smaller food processing area that meets what we need right now, but size certain components and make certain design decisions, knowing that over the next couple of years, we are going to incrementally increase the size of this box.
What are some of the differences between building something for an N of one or building something for an N of 1,000? Or perhaps put differently, how do you go from like R&D to production? How do you go from this is the right mixture of cells to create product Y to we're ready to scale?
There is a trade-off or two sides of the coin,
Mm.
which is performance and efficiency. And I think maybe these aren't contradictory to one another, but they are two levers that need to be pulled. And I think when you're thinking about N of one and you're thinking about, 1,000, they need to be weighed very differently. And I think when you are developing a process for the first time, you really want to understand how can we get the best performances possible in the shortest possible time frame. However, when you're then looking at translating that process into a factory environment, if getting the peak performance means that the operator needs to spin around 5,000 times and then touch the floor and do a dance, that's not going to work. And so
Yeah.
you need to understand, like, what performance do we actually need? And how can we create a process that is as efficient and reliable as possible? And so oftentimes it's okay if it's not achieving peak performance, because when we do this 1,000 times, that incremental sacrifice is negligible compared to the inefficiencies that we will be accumulating.
What do you want to learn over the next 6 months?
That's a great question. I think for me, the biggest learning is probably, I'm starting to put a lot of my time and thought into Factory 3, which is our next factory beyond Factory 2. And I am starting to think a lot about higher level trade-offs that we need to make beyond the more technical. I think it's questions around, what Val will look like when we have global operations and how can we set that team up for success in terms of where people are located, how knowledge is transferred, and how we can get and empower effective teams that aren't co-located. I think that's a difficult problem that we need to solve. In addition to that, I think there's a lot of open problems around supply chain and logistics. So similarly, if you're running multiple factories around the world, what does it look like to send product or equipment or people as needed efficiently? And yeah, I'm also always really interested in the customer side of things. So I am always trying to learn more about what consumers want in their products and how we at Vow can create and then scale products that are going to excite consumers and provide them with options that don't currently exist. And so, as much as I love manufacturing and I love technical problem solving, I also really love digging into parts of the business where I'm not an expert.
Yeah, look, I'm so grateful for your time.
Yeah, thank you for having me on here. I appreciate it.